Good afternoon, everyone. My name is Sarin, and here's my mold detector. So first off, on the display, the top row displays the date and time, and the bottom row displays the current actuator states, the current environmental values, and finally, the threshold values. Now, from left to right, we have the button and potentiometer, which is used to control the threshold values. This is in case you want to have a own custom threshold value because you live in a slightly different environment. Here's our buzzer, our monitor. It stays green when the area you are in is a safe state. If it's not a safe state, it turns red. And finally, our UV LED. Instead of using a real UV LED, we have replaced it with a blue one for now. Now, this normal blue one is used because a real UV LED could cause bodily damage. But we do have safety precautions for that, which I'm about to show you. But first, here's our fan. This turns on when the humidity or temperature gets too high to regulate the ventilation to decrease those values. Here's our sensors, the DHT11 measuring temperature and humidity, MQ135 measuring our VOCs. This actually takes 2 minutes to heat up, which we have in our setup process. So when you plug it in, it actually takes 2 minutes before you are able to run the project. And then here is our ultrasonic sensor. This detects humans so that when humans are nearby, you're unable to turn on the UV LED. So this makes it a lot safer to use. Now, here's our SD port, which is it's very simple to just easily slot it in and then pull it back out. And then here behind, we have our cables. So this is the power supply, and then this is to connect to the laptop. Next up, I would like to show you how to use the buttons. So when I press on the button, it turns it into setting mode, where I can change the thresholds, increasing the temperature threshold, or the humidity threshold, or the gas threshold. Now, for example, if I set it to 41 and I was happy with that, I can press long hold, save it to memory. Now this memory stays onto the device even after you disconnect it. So after you disconnect it, reboot the system, the saved values will stay the same. Now, what happens, for example, when the temperature is below or above actually the threshold value? So the buzzer should turn on. This should be a system alert, so it turns red, and the fan turns on to regulate the system. As you can see, all three values work perfectly there. Now, I like my threshold at 33, so I'll save it back there. Now, to demonstrate the use of the UV LED, this would kill the mold. However, if there was a human nearby, this would also cause bodily damage to the human. So that's where the ultrasonic sensor comes into play. When it detects a human, it instantly turns off the UV LED. Now, when I release my hand, you can notice that it doesn't turn back on. This is because it only allows it to turn back on if it doesn't detect a human for the past 5 minutes and if the humidity is still high after that. So for now, it'll turn off until 5 minutes later, where it will turn back on. Moving on, saving the CSV file from our SD card, we can have this. This is an example from my 24-hour test data, where we have the date and time here, where we measured every 5-minute interval. Here we have the temperature, humidity, and gas values, the state of each actuator, and then the range of values during the 5-minute interval. We can then use this to create a nice graph value to easily visualize the data so that we can analyze it if needed. Here's our example data set of what will happen if something went wrong. For example, if the temperature was too high, the alarm state, fan, and buzzer turns on. If the humidity was too high, for example 99%, the UV also turns on. If the gas was too high, the three, same as the temperature, would turn on. However, if a human was nearby taking a hot bath, the temperature would be high, the humidity would be too high, so the alarm state and fan turns on. However, as the human is nearby, the buzzer and UV are unable to turn on.